today is part 2 of 7-7, and we're back here because I thought I wasn't very loud on the last couple of videos. So going back to this method, yeah, we have been talking about composite functions so far, and today we're going to get a little bit more into the domain and range of this, because there was that full sentence in the definition from yesterday about the range of G has to be a subset of the domain of F. And so we are going to get into that a little bit today by first looking at exactly what we're doing with composite functions and then looking at composite relations. Okay, so if you recall, the domain of a function is the x, or the inputs. Okay, and then you get the range, which is the y, or the outputs. Okay, if you were making these tables, you have your x, y tables. Remember, f of x is another way to write y, so you can also have these x, fx tables. Okay, y and fx are interchangeable. Now that we're dealing more with functions, we're going to be leaning more towards the f of x terminology. Okay, so looking at what a composite function is. Yesterday we learned about f of g of x. Okay, if we're doing that, then we're actually taking f of this g of x. Okay, so starting from the very middle, we see that we have an x. We're going to work from the inside out. Okay, so this x is my very first input. Okay, this x is my very first input, which means that's what I'm going to be doing first. So this input is going to spit out this g of x as the output. I'm going to be evaluating that g of x first because it's the inside function. So this x is my input and this g of x is my output. Okay, from there, you'll notice that this g of x is still within the f of x. So from there, the g of x now becomes the input, and the f of g of x now becomes the output. So the composite functions is you're actually evaluating two functions at once. Okay, so we have this x that goes in our g of x, and then once we evaluate that g of x, we stick that into our f function, and then we evaluate the f function at that point. So we have this input of x and the output of g of x, and then that output of g of x becomes the input that we stick into our f. Okay, and that is what it means when the range of g has to be the subset, that's an s, I don't know if you can tell, has to be a subset of the domain of f. Okay, so here the range, this is when it's a y, the range of g has to be within the domain of f. Okay, so the outputs of g have to be able to be put into the inputs of f, is basically what it's saying. And this is why. Because you have input, output, output. Okay? Alright. So, here we're going to look at some composite relations. We're going to suppose that f is just 3 ordered pairs. Relations are just ordered pairs. Functions are infinite ordered pairs. Relations are a handful of them. So here f is going to be 3, 4, 2, 3, negative 5, 0. And g is going to be 3, negative 5, 4, 3, 0, 2. Okay? Our first one is that we want to find g of f. Okay? If we're doing that, that means that we're finding g of f of x. Okay, which that means, order of operations, we want to do inside the parentheses first. That means that we have to evaluate, so we're going to evaluate f first. Okay? So, if we do that, our inputs are going to be 3, 2, and negative 5. Okay, so if we're evaluating f, we're going to have our first inputs. We'll call those I. F. Okay. We have 3, 2, negative 5. Okay, those are all of my inputs. The outputs I'm getting, this is my input, this is my output. So the output I get when I put in 3 is 4. The output when I stick in 2, I get 3. And here, negative 5, I get 0. Okay? This is the evaluation of f. We get these. After we evaluate f, we have those. Okay, because this is our f of x. is our x, this is our f of x. Okay? Now I'm taking this f of x and I'm putting it in to my g. Okay? So, if I have this 4, I'm sticking 4 into g. So what do I get when I put 4 into g? This is my output of g. I get 3. So it's almost like a matching game. 4 goes to 4. This is my x, f of x, and now this will be my g of f of x. So 4, and then I get 3 at the end. If I put 3 in, this one's going right here, I'm going to get negative 5 at the end. And then here are my zeros, I get 2. Okay, so my ordered pairs for g of f are going to be 3, 3, 2, negative 5, and negative 5, 2. Okay? Alright, if we wanted to find f of g, that means that we would have to evaluate g first. Okay, so if we wanted to do this matching thing, we would want g to go first and then f to be over here. Okay, so if we evaluate g first, this is our input, this is our x, because this is f of g of x. So this is my x, and this will be my g of x. And then this also has to be my g of x. And then this will be my f of g of x. Okay? So if I put in a 3, my g of x is negative 5. Then I take my g of x and put it into f, and I get 0. So my first ordered pair here is 3, 0. I plugged in a 3, got a 0. Okay, here with the 4, I put in a 4, my g of x is 3. Put my g of x into f, I get a 4. So my ordered pair here is 4, 4. And then I get to this one. I put in a 0, I get out a 2. If I put in 2, I get out a 3. So my ordered pair is 0, 3. Okay? Composite relations. Let's do one more, and then you guys can do your homework. Well, in class. Okay. I want to find g of f if f of x equals all these and g of x equals all of these. Okay, if I'm finding g of f, what does that mean that I'm finding in terms of x's? That means that I'm finding g of f of x. Okay, so that means that I have to evaluate f of x first. Okay, so we have to evaluate these guys first, and then we're going to match them up with these. Okay, so if I put in 7, shall I make a chart? I'll make a chart. So this is my x, this will be my f of x. Then I have to stick in my f of x to get my g of f of x. So I have 7, 8, 5, 3, 9, 8, 11, 4. Okay, so if I put in 7, I get 8. Here I'm looking for 8. I have a 5, 3, 7, and a 9. This range of f is not in the domain of g, because this 8 has nothing that I can put it into. So therefore, when x equals 7 is undefined for g of f. Okay? If I put in 5, I get a 3. Then I look here at my inputs. I have a 3 input right here. And I get out a 5. So this gives me the ordered pair 5, 5. That one matches up right there. If I have 9, 8, I have no inputs that are 8 either. So that means that when x equals 9, so that's what it is, it's also undefined for g of f. And then I have 11, 4, and then I have no 4 either. So x equals 11 is undefined. So here, for these ordered pairs, my only g of f value is this, 5, 5. Okay? For extra credit, I want you to calculate f of g using this example and see what you get. Okay?